go ahead and get started. There should be a few more people to filter in. Luckily, we were able to overcome some technical difficulties with the audio. So if you are having a problem hearing me, please let me know. But today's VSUG is about Insight's daylighting analysis. It's sponsored by Idaho Power. Oh, let me at least do this. There we go. And my name is Dylan Agnes. I'm a research scientist at the Integrated Design Lab. We are a team of 6 people right now. Jubin actually just left to the East Coast for a new job. Some other services that are also provided by Idaho Power, in addition to the VSUG lecture series, is our technical design assistance. For more information about that, please visit idlboise.com, technical design assistance. In addition to this VSUG, next month we have Tim Johnson from Cushing Terrell about performance modeling for standards and code compliance. And then in November, not on the usual date because of Thanksgiving, we have Dr. Woods talking about high performance classrooms. And then hopefully we can still have a stakeholders meeting. Right now it's still virtual, but maybe we can have an in-person meeting in the future, but that remains to be seen with COVID. Also check out our energy resource library. It's a free resource to all Idaho Power customers. We have over 800 diagnostic tools. Here are some popular categories that are used: thermal cameras, data loggers, flow meters, light meters, etc. But we have a lot more. So for more information about that, please visit our website, idlboise.com/about us, or about ERL, sorry. And here are some more incentive kickback programs from Idaho Power for commercial and industrial energy efficiency. To learn more, please visit idahopower.com/business. So getting into the lecture today, I'm going to briefly talk about daylighting, just kind of give a quick overview and kind of what we're going to be focusing on in modeling for Revit and analyzing in Insight. We'll talk briefly about the history of Insight, how it got here, how to use it, when you should use it, what you should be doing to prep your model before you run a simulation. We'll walk through the simulation settings. Then I have a live demo for actually running a simulation and then analyzing the results and the data and what to do with it. And then I'll kind of just give you a summary of like what I think about the program, how it compares to the lab's process and what we use, and you know, what are its strengths and what are its weaknesses. So daylighting is the controlled emission of natural light or sunlight into a building for the purpose of illuminating a space. Daylight harvesting is the controlled emission of natural light or sunlight into a building for the purpose of reducing the electric lighting and overall energy consumption, kilowatt hours. And so this is the diagram I made for, in the gold is when you should be really thinking about energy efficiency, building and technical integration. But what we're interested in today is daylighting. And so where that's has the most impact is in the pre-design and the schematic design phase. So pretty early on in the design method. So in the pre-design, you should be looking at the building characteristics in regards to its form and shape, orientation, glazing, window to wall ratio. That you should also be looking at the site, the context, climate, and weather. And then after that, after you have that data, you've analyzed it, you should be looking in the schematic phase on what daylighting strategies are most optimal, i.e., you know, skylights, clear stories, just side lighting, what control strategies you're going to be using as far as glazing type, shading, light shells, site context, and sensors. So for site, using Revit and Insight in most analysis programs, this is just data you load in, and it's either prepackaged and configured, like the climate and weather data, or you have context where you're just filling in the variables as you go and as need. And pre-design, you should be exploring options related to orientation, form and shape, glazing, window to wall ratio, to see how the performance is being affected. And so what they mean by collecting that data is your site comes with context. So it's important to understand your site because it will provide you with data to help you get started. For example, what strategies, if any, are the surrounding buildings using, but also note the orientation and the width. If possible, conduct a survey or study of the surrounding buildings. And lastly, your building should take advantage of the sun path as related to the latitude and longitude. However, other site conditions such as circulation, wind, or obstructions should not be disregarded. So you should have, when you're using Insight and trying to forecast or simulate analysis on a building's performance, you kind of want to try to get the best. What's the orientation, the window wall ratio, the glazing, going to get it to be its best, maximum performance that we can get out of it. And then you start messing with it, taking away from it to give way to other hierarchy of demands in the design process, and you know how much you're losing, and you know what the trade-off is. So other things you to be investigating is optimizing the building's footprint for daylighting. So investigate the exposure on the south and north facade to figure out how much glazing for window to wall ratio you would like, as well as meets it. So say you have 8-foot windows on the south facade, it's meeting your performance, your criteria, but you investigate if you move it down to 6 feet for the height and leave the width alone, and it's still meeting your criteria and performance for certification, then you just save money. Another thing to investigate is the correct ceiling, open, drop down, or inclined. You'll mostly see a drop down just for cost. Open, while it's nice to have an open ceiling, there is sound problems that come with that, as well as you're losing control of potential daylight that comes in from clear stories or sidelights, or side lighting, such as windows, just because it gets that one bounce and it's up and it's out and away. So it's not being redirected back into the room, further into the space. I'm not going to go over the daylight pattern guide yet. That's going to come up a bit later as well. But you want to also investigate the floor plate depth, just exploring different options, either through mapping, just exploring different widths to see how far, light has a limit to how far it can be distributed into a space. So, and that's different for each site. So you can investigate to find, the optimal width of your building for that. And then you can, go above and beyond, not above and beyond, sorry, but either below or I guess wider or shorter than that, and you'll know the effect it's going to have on the performance of the building. You can also take it a step further and investigate the interior furniture partitions near the perimeter of the building. It's recommended that they be at least less than 30 inches, but you can see the effect on the performance in a space by adding and modeling those and including them for the simulation. Another important, probably one of the most important factors about daylighting modeling and analysis is the glazing. So understanding how VLT is expressed, as well as how light behaves with glazing, because not all of it is transmitted. Some of it is absorbed, reflected, re-radiated, etc. And I'll get into the specifics of that for Revit in a moment. But when we're talking about measuring light, there are two units predominantly used. Lux is the unit we use for scientific analysis, 1 lux is the amount of light from the same source at 1 meter. And you'll typically see it in a LEED for the US. Everywhere else, it's kind of the standard. What you're probably more used to is foot candles. It's a unit of measurement for code compliance. So 1 foot candle is equal to 1 lumen per feet squared. And you probably see it most in IECC as well as IES, Illuminating Engineering Society. And so we're going to talk a little bit about code and LEED and how you get your how you should present your data, or how if someone is giving you data analysis, how to interpret that data. So the 2 main ones for LEED are spatial daylight autonomy and annual sunlight exposure. So SDA is the percentage of space that can be daylit most of the time. So it's expressed as SDA 300 over 50 at 55%. So what that's saying is at least 55% of the area is illuminated to 300 lux at least 50% of the time. And so you can change that. So if someone gives you an SDA, and it's 450 over 50, then what they're saying is it's 450 lux is the standard that they were trying to hit. ASE is the same, but it's used for trying to detect glare, so we can determine what spaces will need additional control strategies. It's expressed in a similar fashion. ASE 1000 over 250 at 13% is saying that no more than 13% of the space receives more than 1000 lux for more than 250 hours per year. So other factors is the daylighting factor. This is in its beta version for Revit. I don't recommend using it quite yet. But it's the ratio of indoor to outdoor illuminance, typically used for analyzing light uniformity. So it's typically give you a quick ballpark estimation is what you use that measurement for. And then, as mentioned earlier, the Illuminating Engineering Society has a foot candle guide, as well as a complete listing in the IES foot candle handbook. So you can just Google IES foot candle recommendations, and you should be able to find a PDF from a lighting manufacturer. Lighting manufacturers also print and distribute their own recommendations for their products. And we're going to talk about, when I do the demo and start talking about Insight, I'm going to be referring to LEED v4. Right now I'm going to talk about 4.1 though, the updated version of it. It's relatively new. I just had a project with it this year, so I just kind of wanted to bring that up. There's more options and flexibility with this version. So option 1 is still the typical using SDA and ASE, a standard, trying to meet it throughout the year, 8 to 6 p.m. running simulation. However, instead of having just 2 thresholds, there's now 3. You can get 1, 2, or 3 points, and it's 40, 55, and 75, whereas before it was just 55 and 75. And the conditions for the simulation remain the same. You don't really have to worry about this in Revit. Once you select, there's an option for LEED certification, as well as SDA, and once you select those, they take away the options for you to select, and they default them to the standard. And right now it's just V4. There isn't an option right now for 4.1, but it is supposed to be coming. So option 2 is basically the same thing, except you're going to be choosing a day at 9 a.m. and 3 p.m. on a clear sky, preferably the equinox, for each regularly occupied space. That's another change. And 4.1 is you're allowed to apply for exemptions to the regularly occupied space. So basically, you can contest a space being regularly occupied. You can say, I don't think it is. You can give justification in your LEED forms, and then you can subtract it from the simulation results. But this option also comes with 3 levels of points, so 55, 75, and 90. So it's a lot easier to hit your luminance values with this option, so that's why the percentage of the floor area has been increased. Whereas the last option, it was generally a lot harder to meet that threshold. And there's also a version for healthcare. So here's option 2, continue. So basically, you select one day within 15 days of September 21st or March 21st, i.e. the spring and fall equinoxes, and you use the average hourly value for the 2 selected days. And so the last option, it's new. It kind of threw me for a loop the first time I had to go through it. But so the point system is, it's based off of a percentage of floor area, but it's different sums. So one is for one time in the year. If you want additional points, 2 and 3, then you have to do a secondary measurement and take the average of those. Same standards for grids and everything applies, but kind of here's a table of kind of explaining that. So if I took a measurement in April and I wanted to go for more than 1 point, if April met the threshold or standard, then I have to take an additional measurement in August to December. So you can kind of investigate and figure out which month your building is going to perform best, and then pick those days, pick those months, pick the most optimal day within the month, and then run that simulation, and so your building can meet that threshold to get credit. Okay, we're going to shift gears a little bit and start talking about Insight now. So Insight is a product of Autodesk, which I'm sure you're all aware of, through CAD, Revit, etc. One thing to know about kind of the evolution of building, or I guess, AEC software technology to assist in the design and development of the process is that it's often overlooked that the economic viability that each new model methodology facilitated was through reducing time and money expended on a project through accurate cost estimation and decreasing the request for more information or reworks. So while we like to kind of hold up like we're taking another step forward towards the integrated, design process and method and bringing the industry together, really, in my opinion, what's doing it is just the cost saving through time and money, being able to just forecast data to figure out those timelines more efficiently. And something to know about computer performance is we've seen a decrease of hardware costs and the increase of computer speed and storage since the 70s, which has allowed BIM technology to be developed for applications such as complicated building modeling through digital constructions, accurate information for project constructions, fabrication, and analysis. And so the one you're probably most familiar with is Revit. Revit's not the only one out there, but it's what our focus is going to be today. So the first paper describing BIM was published in 1992, and you can see an upward trend towards the publications for figuring out how far we can start to push the building information modeling realm of research. So effective of March 2015, Ecotech is no longer available for purchase or use. So this is kind of, Insight is a distant relative of Ecotech, which out of Ecotech kind of came the Green product family. So you have, Green Building Studio. Green Building Studio kind of just became an engine, and its user interface got pulled out and developed into Insight 360. And then Insight 360 went from, something that was locally installed and locally updated and locally used on your computer to Insight Cloud-based, which requires just a plugin and a connection to the internet. And so the aim is to allow Autodesk to shift resources, maximizing development efforts on BIM and cloud-based solutions for building performance analysis and visualization. So Insight comes with the Revit AEC collection subscription figure. It's installed as energy optimization. You need to download, install the Revit plugin to use solar radiation, daylighting, or the heating and cooling loads feature. So Insight's goals is that its understanding is that typical energy modeling programs are often complex for architects to use during the early stages of the design, resulting in building performance analysis being performed at later stages. So it wants to address that issue and start to bring that performance analysis a little bit earlier in the design. And it also understands that the profession lacks established methodologies and protocols to incorporate performative analysis into early stages of the design. And so, as we talked about earlier, massing, orientation, volume, shading, daylight strategies, all those in the pre-design and schematic design phase of the project, that is when they have the most impact on rate of return. So here's, and I want to start with this quote from Ian Malloy. He's the senior product manager of Insight. The point from day one is to not quantify the amount of energy, but rather provide the opportunity to enable a conversation with the architect, engineer, and client. So Insight wants to give you direction and accuracy. And by that, I mean, it wants to get you within 10 feet of your, destination if you're using a GPS going somewhere. It wants you to use it from concept to detail. And it wants the architect and the engineer to definitely be working together and consulting with each other a lot sooner, and when necessary, bring in the client. And it also wants one model, and it wants you to do it every project. Whereas what it sees as the industry standard is, we need to know exactly where we are, exactly what our heading is, and by the time we do that, we're usually in detailed design, and we're handing it off to a specialist or a dedicated engineer, who that's usually all they do. And they're taking it out of the program into a separate software program for analysis. So there's time lost and wasted there, as well as, data that could be lost in the translation. And typically, it might be only used for special projects. So LEED certification, standard, 2030 challenge, or the client has expressed interest in going above and beyond. And so Insight leads to PAM, which is parametric analysis and modeling. So parametric kind of refers to the multitude of options that are available at any given time. And so, you could have a window or a curtain wall on your south facade, and you want to investigate at 20, 40, 60, and 80% window to wall ratio. You could set those parameters up and then run that simulation for each one of them and get the results and interpret them to see, a spread on the graph of how spaces are performing with the window to wall ratio, as well as how it's, impacting your heating and cooling loads. And so the way Insight does that is it uses the Revit BIM locally, and then it uploads your model to the cloud to perform those analysis and run those simulations. And so you put those two together, they're pretty powerful. That's what Insight's really knocking on the door for energy analysis. They're not quite there with daylighting though. Oh, sorry, I gotta commit someone. So Revit 2020 with Insight. First thing you do, before you do anything, you open up your project, new model, architectural template. First thing you do is location. There are a couple of ways to set location in Revit. Since we're going to be using the Analyze tab, I'm just going to point out where you can do it in there. It's under the Energy Optimization menu. And so what we're interested in today is the lighting aspect of Insight. But setting the location, this is what you're going to get. It's very similar to, SketchUp and other programs for, locating site. Just enter the project address, and it's going to give you, where it thinks it is on Bing. And then it's going to give you an option over here on the left for weather stations that you can use, and it's always going to default select the closest one to your site. And you can take a look at the averages of your weather just to make sure that they're correct, and you can see what file it's going to be pulling. So model preparation, some things to do. As I stated earlier, glazing is probably one of the most important variables in daylighting analysis. There was a critical update in the past year for lighting V4. So Revit finally changed its material specification, whereas before you would have to specify a certain RGB value, and that RGB value would translate into the amount of panes, thickness, and VLT you wanted that glazing material to have that it was assigned to. So they added new materials because they updated their engine to V2. It's still a proprietary system, so we don't know much about it, unfortunately. But if you use one of those updated materials, you no longer have to do the RGB formula, which I'll talk about in a moment. So materials will have the VLT as a new line option that you can see. However, you cannot change it. It's preset default manufacturer. You cannot change it. So that's one trade-off. So how you get there, you're going to select a window. You're going to go to Edit Type. And you're going to go under Materials and Finishes. And under where the glazing or the glass panel material is located, click on that one. It's going to bring you up a menu, Material Browser, for you to view the properties of your glazing. And so this one I have selected in the example is a new one. And so you'll see it has a visual transmission of 0.507. So about 50 to 51%. And so quick thing to know about this is to change this this property. So I have it select clear insulating low E. So to edit this type, so this is where all this information is being pulled is from this file, this button, which leads to this library. And so you want to click Appearance. You want to go down to Glass, and under Glazing, you're going to, sorry, I thought I was actually in the program for a second. I apologize. There we go. And then you're going to choose the one you would like. And so, unfortunately, you can't view the properties of these until you pull them in to this menu. So that RGB value I was talking about, this is kind of what it equates to is visual transmission is equal to RGB divided by 255. So a RGB value of 127, 127, 127 would be 50%. If you don't have straightforward, as in you want to add some panes or thickness or change the thickness of the material, then you change your RGB value, and that's the second bullet point of how you would do it if they're all weighted differently. So, and it does, like I said, it's trying to get you close to your destination, but not right on top of it. So that's why you'll see, like the default results, there's a range of 15 or 5 to 15% will yield accurate results. So it also goes back to GIGO, garbage in, garbage out. Make sure all your settings are proper and correct. Otherwise, you're going to have a problem. So something to note about this update and new system. As I showed you earlier, they're both on their class under Glazing. In R20, not R19, they're going to have a caution symbol, yellow exclamation or yellow triangle with that exclamation point inside of it, letting you know that it's an old glazing material. And so what that means is you have to use the RGB value to compute the thickness and the visual light transmission. So in R20, you have the option of doing both. And I believe it should also be available in R19, but I'm not entirely sure. I couldn't get a lot of stuff to work in R19, to be honest, which is why I'm using Revit 2020. And one thing that this is what I pulled from an Autodesk forum from developers. And something to note is the value shown for visual light transmission is currently incorrect. When this bug is patched, we will post full documentation for this glazing type. So right now, I'd recommend sticking to the old glazing materials that you can set. It's a little more cumbersome in calculating the VLT, but you'll actually know what your VLT is, and that's more important. Another thing to note is facade and interior building material specifications will have a significant impact on daylighting. You can edit preset wall types for simulations, and always copy, then edit. You want to preserve file integrity and make sure you always know what the baseline is, so you always have a reference, as well as, you know, if you mess something up in your edits, you can go back and you're fine. But same thing with the glazing material. It's just different menu, but they lead you to the same place, the material browser. So instead of looking for glazing, you'll be looking for, you know, gypsum board, wood paneling, you know, ceilings, compact, etc., and editing those materials as you need. So rooms are very important. Rooms are primarily used for creating schedules and organizing the building information with context around it. It's a good idea to fill out the information to the best of your knowledge or available information. When you use Insight, though, rooms change a little bit. So create a room schedule as normal, but if you have Insight installed, you're going to notice there are Insight fields and values that you can populate your room schedule with. If you don't create a room schedule, don't worry. Insight will create one for you based off the rooms in your model, and it will just have the default values for the simulation. The default fields, though, is just the first two, included in daylighting and automatic shades. If you have the Insight plugin and you create a room, those automatically show up in the other, but nothing else does. You have to add those yourself. Use the include the daylighting option for your regularly occupied spaces. So if this is checked, that means Insight's going to collect data during the simulation in that space. If it's unchecked, it's going to leave it blank. And if you want to do mapping, something to note is when you're modeling a mass, you have to place floors as well as walls and roofs. So that's what this shows you where those features are in the menu. The reason why this is important is mass forms that don't have a floor assigned will be treated as a shade object. So you have to give it a little bit of building characteristics for the program to recognize that you're not just modeling site context. And in running daylighting analysis, I would not recommend actually modeling any site context. The program currently doesn't really have a good way of identifying different features from the site, like what's a building versus what's sidewalk, what's asphalt, what's a tree, you know, the opacity of that tree throughout the year, etc. So a quick checklist, key variables to go over will be glazing, material specification in your rooms. Required variables, so you will not be able to run a simulation for daylighting if you do not have at least one level in your model. An enclosed space with a room defined. So floor, walls, roof, basic. And like I mentioned earlier, you can get away with massing, so you don't have to design too much. And you must have glazing. So if you don't have a window, there's kind of no point in running the daylight simulation. Recommended variables, double check your ceilings, your walls, and your floors. You know, make sure they're all connected, they're all in the proper levels, at the proper height and offset. You don't want your ceiling coming below your top seal line, because that will impact daylighting performance. So this is the default menu. You get on the left when you click the lighting button. And it's definitely it's not the same level of development that the energy side of Insight has. And then there's a drop-down menu you can select. When you do that, you can select your option, and this export feature comes up. And this is how you tell what version of Insight you have installed. So if there's a bug or a problem, you can know what version documentation to review. So when you click the export, you have a couple options. You can upload it to Insight 360, so that will connect it to your Green Building Studio account, which could then possibly connect to the actual Energy Insight interface. You can get XML for Dynamo, which is a Revit plugin, or just XML for normal, CSV, Excel. So if you want to take the data points and extrapolate them in another program, you can do that. Not entirely sure what the last two file types are, to be honest. I haven't found them out yet. So it comes with a default name and results, which is basically just the simulation type you selected. So to change that, you select it first, and then you click this pencil icon, and that'll let you change it. Be warned though, keep your title short. It doesn't appreciate, I think, more than 180 characters, so it's not a lot. So one thing real quick before I get into the demo, I wanted to talk about, so say you do select Run New Analysis and you hit Go. This is the menu you're going to get. Real quick, I want to talk about the environment, specifically the sky model options. You should always select the Perez all-weather sky model. It's a mathematical model used to describe the relative luminance distribution of the sky dome. It has essentially become the de facto standard model for daylight calculations. Radiance is capable of using this model. However, we typically use the Reinhardt. It's just a little more precise. But I don't want to bore you with the rest of that text. So to explain that, I'll kind of give you a visual. So basically, we're creating the sky dome with the sun's trajectory and positioning from past data collected at weather stations. And so this same weather file is used, in Energy Plus to run simulations. So I highly recommend you use that option. Okay. Let's get started. So here's Revit 2020 with a model I made. So first things first, set site location. So as I said, you can do that. Yes, go away. You're going to do that here. You can also come down here to the sun path icon, click on sun settings, and you can do that here. If you go up to still, You can see because I set it over there already, it pulled information, so it's set here. So once you set your location in, that should be first floor, one part of the model, it's set in all the rest of the model. So there are a couple places you can do that. But let's go here. Okay, I'll stay there for a second. So this is the option you get. So you're going to select your analysis type. There are a couple. I don't recommend using daylighting factor. It's really a ballpark estimate that you can easily get just from looking at weather data. It's also in the beta phase for them. Illuminance analysis, this will kind of give you a single point in time. This is good for investigating option 2 and 3, where you're choosing, 9 a.m. and 3 p.m. on the fall or spring equinox. You can investigate those days here with the luminance analysis. There used to be lead V4 EQ7 option 1, but that got changed to daylight autonomy SDA preview. And so if you'll take a look real quick, so you see I have options to, lux the foot candles, change the grid, change the threshold, the analysis plane. I can go in. So this is the weather data I was talking about. So make sure you have this option selected, and it's going to pull that weather file. And if you perform, say, an energy analysis on this building, you're using the same data, so it's consistent. You can, change the day, time, etc. But you'll notice that when I select SDA preview, all those go away. So it defaults to the standard that you need. If you really want, you can go in and you can mess with it, but I don't recommend it unless there's a very specific building use or type or space use type that you need to investigate. And then, the 2009, if you're going for lead 2009, I mean, you're on the last boat. That's almost going to be retired soon, I believe. And so the option 2 is basically ASE, the annual sunlight exposure. And then you have solar access, so just measuring the amount of solar hitting the building over a period of time. So you can do that on a specific day, through a time range, set your threshold and whatnot. The most important feature, though, to draw your eye to is down here. So cloud credits. It's not entirely free. I cannot give you the ratio of cost because I am very lucky that when I hit check price, I have an education license, so I don't have to pay cloud credits. But so when you do run a simulation, I've already run a couple already. It's going to give you a new 3D view. So here's our normal Revit 3D view, and it creates an insight view as well, so you can see in 3D. But it's not entirely helpful. So it also makes a floor plan view if you have rooms and the floor plan in your view pane. It's going to do it automatically, and it does it for second floor as well. There we go. I don't know why that keeps going on top of it, but it does that every time. Another thing, call your attention over here. It creates a floor schedule and a room schedule for you. So here's the room schedule I made already, before I ran the simulation. And then this is the one insight will give you. So you can go in and afterwards, change what's to be included, what's not, what will have automated shading. It just pulls the default, very basic information from your rooms. So I do recommend making your own. So if you want to go between your simulations, you see I run quite a bit. This is kind of what they get stacked up as. So I definitely recommend coming up with a naming nomenclature for sorting out your files. To recommend to see what they are. We're going to click on that one. So you're going to just hit go, and it's going to launch your results into the model. It takes a moment. And so every time you do that, whether it's a fresh simulation run or it's an old one, it's going to give you a result summary. Come on, I'm clicking on it. Thank you. So this one, as of right now, is not going to get any points, unfortunately. If it was being applying for lead credit, the building's not, though. And so I'll tell you, 16% of your rooms meet SDA for 55%, 11% meet the SDA of 75%, 16% of the rooms ASE is over 20%. So it kind of gives you an overall breakdown. And a cool thing I found out while investigating this is if you click on design tips, it's going to start talking to you about daylight autonomy, just things and features. So things I've already talked about, but it specifies daylight patterning guide. So if you click that, that leads, oops, come on, there we go, to menu. I don't know why it does that though. Oops. It leads you to the daylight patterning guide the IDL helped develop that I've showed before, and so that's why I was saying I wasn't going to show it earlier in the presentation, because Autodesk actually tells you you should also go consult this guide. So please do. It's very helpful in my opinion. So this one, the menu can't really stay up. I haven't figured out a way to bring it back up after you close it. So just be known, you might want to take a screenshot or write down your results of the summary. You can also kind of get a different formatted version of it in the room schedule. And so for this one, the legend is set up for SDA pass-fail, so you can see what's passing and what's failing. When you click off of everything and just leave that on, so nothing in the model is selected, you come over here to the left to the properties. You're going to see your color schemes. So right now this is set up as pass-fail, but there are a wide range of default palettes that you can select, and you can go in and edit. So say you didn't prefer, just these colors, yellow and gray, you could change it. You can also mess with the legend and the units. And I can't show you on this one, but I can on another one, I believe. Just do that one. Sorry, just one moment. There we go. So this one gives you a different summary because it was lighting analysis, whereas the one I just showed you was spatial data autonomy preview. So it tells you the average, so 21% passing, tells you 9 a.m., 38% passing, September 21st, 3 p.m., 40% passing, September 21st. So you click off that and say you don't really like this color scale. So with SDA and ASE, you're kind of limited to just that one format of pass-fail, but the other ones, not so much. Like you're probably used to seeing this palette. So, and so say, I wanted to get a little more precise, like what does blue mean? What does green mean? I can go in here, I can add the ranges and the steps and how the legend's calculated. So you can also, again, copy then edit. Don't just mess with the default. And then something to note is if you do click on the actual gradient and come over here to analysis results, you notice we ran the simulation at 9 and 3 p.m. So right now it's selected at 9 a.m., select 3 p.m., and now you're looking at 3 p.m. And say you wanted the averages. Well, that's what the averages would look like for those 2 days, or for those 2 times on that day. And you can also bring in past simulation runs. And then this is, so then if you go to results visibility, let's change that real quick back to 9. You're going to get, is it visible, is it not, display style you can mess with. But this probably more important is you can change foot to lux to foot candles here. So you click apply. So the value changed and the scale changed, but this did not because it's a separate entity. So you have to go in and edit this yourself to change that. And if you don't want that, then in the analysis menu, instead of, so hit go, so you can change from lux to foot candles, and it'll help change that, what I was just talking about. So, and it defaults back sometimes when you select the menu, but, so it's different for every view. So you can see the second floor plan is still on the original scale defaulted to. And this is what I'm talking about when selecting include in daylighting. So even though this space is getting some amount of daylighting, it doesn't need to be included in this analysis because it's not a regularly occupied space according to LEED. So those are a lot of the options. I know I've talked a lot and didn't give opportunities for questions, but I wanted to make sure I got to the demo. So does anyone have any questions about the program or features or options? And, just like any view, you can, export this, take it into Adobe, Photoshop, etc., process it for a report or presentation or a document submission. So we've launched a poll. We would appreciate if you could fill it out. Do you apply view templates to the lighting floor plan that you have up on your screen? Yes. So I prefer. I don't actually use Insight daylighting analysis for our current projects or design workflow, but you can make one. So it's just selecting it. Or no, sorry, not just selecting it and then going to default analysis display style. And then you can set it. But as far as what I use, I believe, yes, I have. I prefer something like this. For this project, normally there's a floor plan there, but there was a quick turnaround for the project. So they were fine with just letting me do that. But generally, I kind of use a couple of ranges. So I have black for underperforming. Blue is the sweet spot, the minimum. So as long as everything's blue, we're good. If it's green, okay, awesome. It's really performing well. It's getting, more than it needs. Yellow is a little concerning. Definitely want to double check that area for our ASE values. because it's saying it's receiving it 100% of the time throughout the entire of the year. And so, I found that this is pretty easy to digest visually. As well as I'll do something like this, depending on the options selected or what I'm being asked to run the simulation for. And then, the ASE is a little different. So I have, basically you want everything to be black. And if you start seeing color, it's bad. If you start seeing a lot of red, it's really bad. So, just visual cues like that. So, very, very simplified palette. If you're going to do a visual presentation of the data, like, the Revit floor plan. So yeah, there's that one. There's this one. So like this one is, I was messing with some settings, just kind of turning it to min and max and figuring out how to get it, how to play with the settings, their constraints, so to speak. So this is one I developed. That's why it was the default, was because I was just messing with it last. Normally when you do it, it is going to give you the actual default, which is lighting analysis default, or the ASA or SDA ASE default. So I hope that answered your question. So if that's all, no more questions, I'm going to say goodbye now. I will be posting a follow-up about insight, energy, and daylighting analysis to our website for a BSUG blog. So look for that. And have a nice day. Thank you. Probably end pulling first.